Okay, I'm back. Jesus Christ. Alrighty. I know I'm kind of looking generally, but I want to give myself a reference in the future of what to look for and what to identify. Never forget the basics. You need to understand the basics, and right now I'm kind of looking at the notes itself. But I kind of need a refresher of the basics because right now I'm kind of going too far into the advanced, and it just gives me a recap of what the basics it is. dz equals free stream. This determines the okay, I know this. du over dt plus u du over dx plus v du over dy plus w du over dz. Jesus, negative 1 over rho d rho over dx, because this is x, determining the x momentum, I think. Momentum. Plus nu, then u over dx squared plus dy squared plus d partial derivative. Sorry. Yeah. There's two more equations in which all it is, if you're in a v field, it's going to be du over dt plus u dv dz equals negative 1 over rho y plus nu. This is not a v, this is a nu, this is a variable determining the, I think the flow. V, this is a v. V squared y squared plus v over dz squared. You get the idea. Replace this. The next one, omega, which is just www, dz, omega. During the sense, that's going to be an Stokes equation, x momentum, y, and z momentum. I'm going to leave this here because we're going to need that later. Okay, so I'm going to skip this. I'm going to go to pipe flow practice because we can recall this in the practice in vector calculus, where I had to find the pipe flow equation. The Navier-Stokes equation cancels out for pipe flow. Sorry, it was let's say pipe flow. The Navier-Stokes equation cancels out to be negative 1 over rho d rho dx equals, no, sorry, plus nu du squared plus dx squared plus du squared plus dy squared. No, sorry. What is going on with me? This is a practice problem. This comes out true. I forgot the reason why. Sorry. This was a little bit ago. This was like a week and a half ago, but I need to recall that. Using d rho over dx equals negative g, which is the gravitational pull, Newtonian constant, leads to d squared u over dx squared plus d squared u over y dz. The reason why I'm seeing right here, it's this. Negative g. It's recalling for with r, this is Cartesian coordinates, square y squared plus z squared. This is the example given. So as we're given that, generally the equation for pipe flow is it's not enough space. U r equals negative, let me get it, whoa, I know it's, is it negative? I'm stupid. It's g r squared over 4 nu rho 1 minus r over big R squared. And yeah, it's determined by the vector field later. Okay, leads to negative g, and then we're given r equals square root y squared plus z squared square root. So right now we're in a y to z plane. Y to z plane. So really we could, I mean, d over dr, r d over dr equals negative g r over nu rho du, I'm sorry, Jesus Christ. UR to 0 constant, the boundary condition, there's no slip, so there's no boundary condition. So UR equals 0. Big R. I'm sorry, I'm very stupid. So we integrate. We get we're getting rid of R. So R, right? Yeah. R squared over 2 nu. Then you convert R to big R. Yeah. Then we get U R equals fuck. Excuse my language. GR squared divided by 4 nu rho 1 minus square root y squared plus z squared divided by r squared. What? And then this is really just plug. What? Wait. Rho 1 minus squared, and this is the answer. Yeah. And the x vector field. Yeah. That's the answer I got right here. Yeah. So the pipe flow. Cartesian space. Right. Yeah, this is. Yeah. Yeah, that's right. Correct me if I'm wrong, whoever's doing this, whoever's the genius behind all this. This is just week 1 of my capstone project, so understanding this is kind of crucial. Vorticity. Okay, we're going. Okay, I'm gonna go in a. Oh, it's only been 10 minutes. I'm gonna go. Let me drink some water. Okay, so I'm gonna take a break of this. This goes into vorticity, but first I'm gonna derive it to get the. Okay, this is vorticity equation. Generally, this is generally what it's supposed to break down to find del curl omega curl u. And it gives the vector field, yeah. I'm going to do the complicated way. I'm going to try not to review. I try to remember this. But the vector identities and the rest is just, it's easy. Understanding vector identity, that's basically what it is. And proving it. Then, after deriving the Navier-Stokes equation, I'm going to go into two-dimensional flow, curl, vorticity, velocity. That is easy. I'll go review it furthermore this today. And then I want to go into stream function. Then stream function, Cartesian coordinates. Cartesian coordinates are very two-dimensional plane, where it's just an x and a y, basically. Here's an analogy here. Two-dimensional incompressibility condition in Cartesian coordinates given by d over dx plus dv over dy equals 0. Basically what it is. Stream function, where u equals partial derivative of stream function divided by dy, comma v negative v. No, sorry, v not negative v, because I'm imagining a future equation. The future equation is basically u dy times negative. No, I think is plus. No, minus v dx. It's kind of a bit. Well, beside the point. Negative d rho dx. That's basically what it is. I know that sounds. I'm kind of going confusing, but beside the point. Let's get started. Put that there. I'm gonna do my best remembering this. I've done this in a bit. Not a bit, a few days. Okay. Ooh, that was a loud crack. Okay, we're gonna use continuity. Okay, we gotta take. Okay. No, sometimes. Del. No, this is 0. Del curl. So Laplacian. Del curl u. Okay. Okay, using earlier learned continuity. Is this how you say continuity? Continuity results. Okay. Del. Yes. Okay. There we go. Now we're getting somewhere. Equals shit. Negative 1 over rho. Del squared rho. Shit, why don't I remember this? I know the new not Newtonian, Einstein summation form and how to properly do it for this. You know what? I'm not gonna do it this way. There's different laws in the back. They're really easy. I mean, Gauss's law is generally S. Yes, S E ds equals epsilon That's really easy. Okay. I am not going to use this. I'm going to use the other one because that other one is more specific. The set of I'm going to throw this away, really. I was kind of confused too. More you guys are more involved into that. Okay. Okay. Let's solve vorticity equation. I'm gonna get this the hell out of here. Vorticity equation. Okay. Well, vorticity is mainly the flow's geometry, kind of. It's like, here's a good analogy, is when a plane goes through a cloud and you see, so there's a wing, and it passes through a cloud and it curls. That's basically vorticity itself. Navier Stokes equation helps prove it, and furthermore, it gives us a good understanding of the flow itself. And we can go into Gaussian, Raymond's number. What else? SOR equations, entration equations. There's examples, but that's what I'm learning now. It's a lot of stream functions in omega. But beside the point. Okay, omega equals del U. Okay, now what we have is it's horrible. I'm just gonna write it. I think I remember it. Du over du, I think it's du over du plus u dot del u. Is this right? Curl. You take the, what am I doing? Del product, not del product. Du over du, right? Du over du is u vector plus u dot del u. Then we get del negative rho del rho plus nu Laplacian u. Okay, we'll convert it to oh, my back. No, okay, we're not gonna go to del. No, d over dt. Why do I keep doing del? That makes sense. You take a curl of a fucking u. Sorry. Del operator knows d. Oh my god, what the fuck is wrong with me? I just memorized this. This is vorticity itself. Not vorticity itself. It's the constant. God, what the fuck is wrong with me? If we do negative 1 over rho, this turns out to be 0. But if we do del and this turns into u Laplacian omega. Okay, now we found that. Don't worry. We found all the factors. Not all the factors, all the knowns, whatever. Okay, this is going to be the challenging part that finally I know, that I memorized. U dot del equals del. Okay, here we go. This is where it's going to get haywire, which finally I know. Okay, We have that. We gotta prove this and that. And this is where my expertise in Einstein summation formula goes. Which is given to me del. Note this. I don't know if you guys can see that. Is del curl omega del u. I mean, del curl omega curl u. I'm gonna erase this to give a general sense. A general sense. What am I talking about? It's gonna get a little haywire here. Okay. Whew. Okay, let's do it. U del u equals. Okay, there we go. Now I get it. There we go. K uj kl m. Watch this, y'all. Watch this. U-M over dxi equals E-K-I. Not E, it's epsilon. Fucking dumbass. Jesus Christ. dxi. Convert this over here. Chronic or delta? Chronic or delta? I, L, chronic or delta? J, M minus chronic delta. I M chronic delta. J L U J D U M divided by D X I equals U J D U D U J over D X I minus D U J. D sub j, u sub j, d u I divided by dx j. Factor out. 1/2. Is that right? That is right. Okay. Oh. Minus u I divided by dx j, which equals 1/2 del u times u minus u dot del times u, which we can say is, and proving this itself. Yep, vector. Then what we have is u dot yep, we proved it. This is Einstein summation. Oh no, did it stop? Did it? Please don't tell me it stopped. I don't know because it's my battery. It's almost about to die. This is Newton's not Newton's Einstein's summation. This is a little gist of it. It goes really in depth, proving the vector calculus identities. We can go into. I'm not going to go in depth with that. That's too much, and I forgot it. Let's go to the next bit. This, call my great uncle and tell him that uploaded this. Okay, as we now know, del curl u dot u. Huh. Okay. Oh my god. Why does my phone keep? I know it's 25 minutes long, but just hang in there with me, please. I'm almost finished with the Navier Stokes equation. Then I'm gonna make a separate video talking about some other formulas. Damn it. Okay. We have del u equals curl 1 over. Okay. This is where you need to know the concept of a curl. If you take a curl, if you take del curl del, then it ends up to be a 0. Is that right? No, that is not right. God, bro. You just did this, Johnny. Come on, log in. Okay. This turns into 0. Curl of curl. This turns into negative curl. Curl u curl d. There you go. There you go. There you go. Wait. Which is just basically whoa. U curl w. Oh my gosh. Curl u. Note that. That's part of an identity. Negative. There we go. That is equal to del curl u dot del u. So hungry, and it's Ramadan. So we proved that del curl u. I'm sorry. That. This is a vector identity. Use the vector. That's basically it. That's really it, basically. Using a vector identity, which is just the vector identity of this. It's really just the usage of yeah, basically. Is it plus? Plus, yep. That's basically it. Generally. And yeah, understanding this can be complex, and furthermore, right now what I'm understanding is, I'll give you a little gist what I'm understanding now. It's, which I kind of got stuck on. It's just streamline functions like this. K plus 1 equals 1 minus K plus R Then this goes into deep. I plus 1, j, I minus 1, j, I, j plus 1, I, j minus 1. Then it goes to h squared e to psi I omega I j. Then omega. Thing is, difference about omega. I'll show you the difference. There's really no big difference. Then I'll show later. I'm really tired. Had a long day today. I know you guys had a long day as well. Hope everything is well. Hope everything is extraordinary. Hope future opportunities tend to drive you who you are, and future Johnny, I hope you are where you wanted to be. I know generally whoever's watching, but I want to say this message to the future. I hope you're a successful aerospace engineer or something related to the field and doing something you love and compensated well. You will do great. Forget that person. And you know what I'm talking about, Johnny. Forget him. Not him. Her. Forget her. Okay? You're already locked in. You're already done everything. You're doing well in college. Well, you're not taking college. CP. But thank you very much, whoever's watching. Please stay focused more. I know, or Johnny, I hope you're able to see this and others. Yeah, I know I need to get a good grasp of it. Still working on that. But, yeah. Whoa, my veins. Have a good one.